Riddle me this, mother lecker.
Alice and Bob are playing a game using a chessboard. This is an 8x8 grid. Alice starts by placing a knight on the board. Then they take turns moving the knight to a new square, one that it has not been on before. Standard chess rules apply. The knight can only move in an L shape, that's 2 squares in one direction and 1 square to the side. This is one possible place the knight could go, and these are all the other places the knight could go from the original square. Each time the knight moves, it has to move in this L shape. The first player who cannot move the knight to a new square loses the game. Who wins if both players play optimally, and what is the winning strategy? So I'll admit this problem stumped me and I could not figure it out. Can you figure it out? Give this problem a try, and when you're ready keep watching the video for a solution. So before I get to the solution, I want to mention this problem is an example of game theory, a mathematical field where you solve games of strategic interaction. Alice's best move depends on what she thinks Bob will do, and Bob's best move will depend on what Alice did and might do. Remarkably, we can analyze these situations and actually find solutions for some games. In this game we can prove Bob can always win no matter how Alice plays. How can we do that? We will use an interesting concept called a graph coloring proof. So let's prove that Bob can always win this game. We start out with our chessboard and we're going to divide it into 8 different 4x2 regions, so 1 2 3 4 5 6 7 and 8. So what's so important about these? Well, let's analyze one of them in particular. Suppose the knight is in one of these squares. Where could the knight go while staying in the same 4x2 region? This is the key to the whole problem. From a square in a given 4x2 region, a knight has only one legal move to stay in the same 4x2 region. So from this square there's only one possible spot the knight could go while staying in this 4x2 region. So what we'll do is we'll color code these 2 squares the same color. So from either of these squares the knight can only move to the other position. This will be true for every single square in this 4x2 region. For example, from the lower right hand square there's only one possible place the knight could go from there, and vice versa. So we'll color these 2 the same color. We can do it for the remaining squares in this 4x2 region. We will mark 2 squares the same color if the knight can move between them. Now what can this coloring do? Well, it'll apply to every single one of these 4x2 regions. So from a given 4x2 region we know there's only one legal move to stay in that same 4x2 region. So how does this help Bob win the game? Alice starts the game by placing the knight in some 4x2 region. Let's say she places the knight here. What Bob will do is he'll then move the knight to the only other legal square in the same 4x2 region. Now the key is that Bob has taken the only other legal square in that 4x2 region. This forces Alice to move the knight to a new 4x2 region. On her next move she cannot stay within the same 4x2 region because these 2 squares have already been visited. So let's say Alice moves here. Now where should Bob move? Well, he's then going to move the knight so the only other legal square in that 4x2 region. He applies the same coloring pattern to that region. In this case the knight is on a yellow square, so Bob is gonna move to the other yellow square. As long as Bob continues this strategy, he will always have a move, and he forces Alice into finding a new 4x2 region on every single move. Alice has to keep finding new squares in different 4x2 regions, and eventually she will not find one. The game has to end in 65 moves or fewer, as there are a total of 64 squares. Therefore Bob can always win this game, and like magic we've solved this problem and shown that Bob can always win. Did you figure it out?
Riddle me this, mother lecker.